We continue with the topic of determinants, where we know that the determinant of a 2 by 2 matrix is A times D minus B times C for a matrix A, B, C, D. And if we want to determine the determinant of a 3 by 3 matrix, we need to know the concept of a minor, which is the 2 by 2 determinant consisting of elements that are left after removing row I and column J. And the cofactor is minus 1 of cofactor of element ij is minus 1 to the power of I plus j times the minor of aij, and this sign of this, so it will be a plus 1 or a minus 1, is given in this pattern, so we know which sign corresponds to which element. It's just an easier way of doing it. So another example where I take matrix A and I am going to they say expand the determinant. I calculate the determinant using the second column. So that means that I start with my element 2 times its cofactor, and so I need to determine that sign. Well, it's element A12, so I know it's a minus sign, times minus 1 times the elements left if I remove the first row and second column. So first row and second column, I'm left with 1, 1, 1, 1. And we go to the next element, which is nice because the next element is a 0, so plus 0, and the sign is plus 1 times plus 1. Times, well, I'll write it out. We remove the second row, second column, and left with 1, 3, 1, 1. And of course this is 0, so I don't really have to calculate it. And the last element is 1. Its sign is a minus times minus 1 times, and what are we left with? If we remove the third row, second column, and we have 1, 3, 1, 1, 1, 3, 1, 1. And let's calculate this. Well, the determinant here is 1 times 1 times minus 1 times 1, which is 0. So we get 0 here. We get 0 here, whatever it is. This determinant is equal to 1 minus 3, which is minus 2. But as we multiply it by 0, it's 0 anyway. This determinant is 1 times 1 minus 3 times 1, which is equal to minus 2 times the minus 1 equals 2 times 1. Equals 2, and we find that the determinant is equal to 2. So we used the second column to calculate this example. Let's take a different one. Let's take the third row. So we would have the first element of the third row, 1 times plus 1 times the 2 by 2 determinant. When we remove the third row, the first column, so we're left with 2, 3, 0, 1, 2, 3, 0, 1. And then we get the second element of the third row, which is also 1 plus 1. And what is its sign? It is a minus sign times minus 1 times the determinant. And we take the third row, and now we remove the second column, so we have 1, 1, 3, 1, 1, 1, 3, 1. Plus the third element, which is also 1, and its sign is a plus times plus 1 times, well, we remove the third row, third column, and we're left with 1, 2, 1, 0, 1, 2, 1, 0. And well, let's calculate this. This determinant is 2 times 1 minus 3 times 0, so this is 2 times plus 1 times 1 equals 2, plus 1 times 3 minus 1, 1 times 1 minus 1 times 3 is equal to minus 2 times minus 1 times 1 is equal to 2, plus 1 times 0 minus 2 times 1, so this one is equal to 2, times these numbers is equal to minus 2, so 2 plus 2 minus 2 equals 2, and it is the same answer. And this just illustrates, and we could do this for all rows, all columns. It doesn't matter which row or column you pick, you will always get the same answer. So there's, for this matrix, well, the third row isn't the best option, because if I take the second row or second column, I have a 0, which means I have one less determinant to calculate. So let's take just one more. I do the second row. So I get 1 times minus 1. I'll just remove these. So we're using the second row now. 1 times minus 1, because this first element sign is a minus 1, times 2, 3, 1, 1, plus 0 times, times whatever. And then this last one has sign minus 1 plus 1 times its sign minus 1 times, we remove the second row, third column, so 1, 1, 2, 1, 1. And we can calculate this, so 2 times 1 minus 3 times 1 is equal to minus 1 times minus 1, and we get a 1 plus 0, and here we get 1 times 1 minus 2 times 1 is equal to minus 1, times this minus 1 times 1 is equal to 1, and we get 2. So we've seen three ways, well, three rows or columns how to determine our determinant. We see that we need our, where's my red pen? No red pen, red pen. If we take, our, for example, this second row, these elements correspond to these elements. We know where our signs are in this grid, and the minors we can calculate by removing rows and columns, and we can speed things up. If there is a 0 or maybe even 2 zeros in our matrix, we use that so that we don't have to calculate one of the determinants. It's just to speed things up a bit. So this is another example on how to calculate the determinant, and in the next video I'll show you what it's useful for when calculating properties of matrices.